In this video, I want to develop the points on our unit circle associated with rotations that are multiples of pi over 4, which is also 45 degrees. So one triangle that comes to mind, one right triangle that comes to mind when we think of 45 degrees, is a 45, 45, 90 triangle with legs of length 1 and the hypotenuse of length radical 2. I would like to use a triangle similar to this in our unit circle. So I need the hypotenuse to be a unit. I need a hypotenuse of length 1. So I want to use this similar triangle. To get from square root of 2 to 1, I have to divide by radical 2. So I'm going to divide the other sides by radical 2 as well. So this is the triangle that I'm going to use in our unit circle. Of course, 1 over radical 2 is the same thing as the square root of 2 over 2. Alright. So far in a unit circle, we've talked about the points on the axes. I would like to add 4 more. So let's rotate pi over 4, or 45 degrees. When I do that, this triangle shows up in my first quadrant. So to figure out the x and the y, well, the length, my x coordinate is just the length of this leg, which is 1 over radical 2. My y coordinate is the length of this leg, which is also 1 over radical 2. Okay. What about a rotation of 3 pi over 4? If I have a rotation of 3 pi over 4, or 135 degrees, then the triangle that I want to refer to is going to be this right triangle, called a reference triangle, right? If this is 3 pi over 4, then the reference angle is going to be pi over 4. So it's exactly this triangle, right? Just kind of flipped over, okay? So the x-coordinate is going in the negative direction now, but this length is exactly the length here. So my x-coordinate is negative 1 over radical 2. Negative because we are on the negative side of the y-axis. Y-coordinate is still just the height, or the length of this leg, so the y-coordinate is 1 over radical 2. And we can do the same thing below the x-axis. Here's a rotation of 5 pi over 4. When I rotate 5 pi over 4, then notice this reference triangle here, it's going to have an angle right there of pi over 4, right? So it's exactly this triangle, just kind of turned around a little bit. Okay. So the length of this leg is still 1 over radical 2. It's in the negative direction for x. So the x-coordinate is negative 1 over radical 2. The y-coordinate is now also in the negative direction. So this point here associated with 5 pi over 4 is negative 1 over radical 2, negative 1 over radical 2. Okay. One more to go. A rotation of 7 pi over 4. Here's my reference triangle. Here's my reference angle, pi over 4. So the x-coordinate is in the positive direction. The length of this leg is 1 over radical 2. The y-coordinate is in the negative direction. Its length is 1 over radical 2. Okay. So the points on the circle associated with multiples of pi over 4 are depicted right here.